Hi, this chapter 10, is on mortgages. We've talked a little bit about loans and we have looked at savings accounts and decreasing the values and payments. We've looked at present value, we've looked at future value. We have looked at paying debts off with the actuarial method. We looked at the USA method, and we also can look at loan rates based on the annual percentage rate, or APR, which we have talked about before as well. So we can just use the formulas that we've used before and setting up the chart to determine what a payment would be for, like, on a 2-year loan. So that way we could compute it and find out in this case that it would be the payment would be $241.72. Take into consideration that when you do some of these, that your calculator might say have a negative value, but it's not negative technically because it's a decrease to the balance. Excuse me, and that's what loan payments do. You can also look at that in a different way. In this one, you wanted to know the payment. The example 2, you don't know what the future value will be. He wants to know what the balance would be after that time period. And so we can plug in the numbers and we can find out the answers as well. Edwin is making payments of $273.59 per month on a 3-year $8,900 loan. In this one, we want to find the APR. So we would find out that's the one that we're missing, and so we plug that into our formula, the same formula we used before in the previous chapter, and we will find out the answer to that. So we have mortgages. It's what you have when you buy a house, and the house is the security for the loan. We have mortgages with fixed interest rates, which is what we're going to talk about right now, and equal payments that are called conventional mortgages. And those are solved in the same way as the typical loans. So if you look at this example, we just plug all the numbers in. We're looking at here at the present value because we want to know how large a mortgage she can afford. And so we just plug in the other numbers and we end up getting the final amount that she would use. So we do want to make sure that we take into consideration that loan balances decrease really slowly at first and then they get higher. And a lot of that could be because you're paying more on the interest at the beginning than you are as you get further along. So in this case, we are looking at all of this information that is given to us. We want to know, the length of the mortgage. We want to know how many periods there are when we look at 12 periods per year. So here's like a graph of what it looks like in the decreasing balance, how it just seems like it slowly goes down until we get to the end of it. This has a $190,000 home, 20% down, financing the rest for 15 years at 4.5%, plus 2 points and a $300 origination fee. Okay, yeah, so we got to take that into consideration in step 2 when we're looking at some of these problems. And so, we can find the payment itself, but then we need to multiply in the points. We need to add in the origination fees, and then we can find out the amounts. And that was that one. Okay, amortized loans, we can borrow a sum of money and we can make equal payments at regular intervals to pay off these loans or obligations that we have. We have talked about before um, principal or present value, and we have looked at it with the following formulas that are on the page, and those are also included in solving these problems as well. So we do have a loan formula, and it looks pretty much like some of the other ones we've looked at, but we have the P is the principal or present value, R is the amount of each payment, R is the annual interest rate, N is the number of periods per year, and T is the time in years. So we want to look at the cost of buying a car. We want to purchase a car, and we need to include the tax, title, license, and fees along with it. We want to make a 10% down payment and pay the remainder through a car loan at an interest rate of 7.9% compounded monthly. So here again, usually with the car loans, like house, like a mortgage, the car is basically the collateral. So if you don't make the payment, they can take your car. But we want to find out what our monthly payments would be, what the total amount would payments be over the entire amount of the loan, and how much you would pay over the life of the loan. What's really cool is most companies will put this out there. Again, we talked about Truth in Lending. They will have these already calculated out for you so that you don't have to. But it's good to know, and even double check them to make sure that they give you the right amount. So we just plug those into that formula. We have the amounts, and we end up that for A, because we asked for the monthly payments, and we found out that that would be R would be equal to about 351.58. Then we can take N times T for 48 payments, the total amount over the life of the loan, and then the interest, which would be the difference between. Okay. The total interest paid is sometimes called the finance charge. So you've heard that term probably before. It can also refer to the monthly interest charged on a revolving credit account, which is like a credit card account. So in this example, we want to know the maximum periodic payments that we can afford and how much money that you can borrow. So that, for example, could be for a student loan. A college senior does not have enough money to cover expenses and plans to get extra money through working and through a student loan that will have quarterly payments for 6 years. She estimates that after graduation, she can afford to make quarterly loan payments of $300. If the loan is made at an interest rate of 7% compounded quarterly, how much can she afford to borrow? So again, we're using that same formula. We are going to plug in the different amounts. R is 300, big R. Little r is 0.07, N is 4, because it's quarterly. T is 6 years. So we use the loan formula to find the amount. Remember that we need to do the things in parentheses first. So make sure that you are, for example, going 0.07 divided by 4, then adding 1 to that. Then you say 1 minus that amount to the negative 24, and then you can get your answer. So here we want to pay off a loan quicker, right? That we always want to do that, but we want to make sure that we are going to be paying it off quicker and not um, not paying enough. What we saw in the other ones where we didn't pay enough at the principal, so we ended up paying more, and it wasn't worth it. So we want to know how much the scheduled payments would be. If you paid $100 extra each month, how long would it take to pay off the loan? And how much does the couple save in payments over the life of the loan by paying $100 extra each month? So why do you want to know that? Well, is it worth it? Is it worth me putting that extra $100 there, or should I put that to someone somewhere else? So we looked at um, the amount we would end up being paid is 1,039.08 rather than the 939.08 that we figured out to be the regular payment when we did our standard formula. Um, and then we want to use that to find out how long it would take to repay the loan. And so that T is what we're looking for on that one. And so we can do our formulas and we can end up with 21.34 years. It's nice to be able to do this in a calculator because this is a lot of calculations. Um, but we do find out in the end that by paying an extra $100 each month, the loan is paid off in 21.34 years rather than 30 years. That's a lot. That's almost 7 years. That's a good amount of money. Um, and so it might be worth it to do that. Um, so then we figure out the total interest saved over the life of the loan also. And that's a lot of money too, $71,000. So think about those things if you are, looking at purchasing a house or a big ticket item, and how paying a little extra each month, but making sure too, though, that you're paying enough that covers um, the interest rate, which you would be doing because you're covering in your original payment. And typically, you do also want to say that you want that money to go toward the principal, to buy down the principal or to pay down the principal. So, finding a loan balance, we want to know what a particular balance is at a particular point in time. This can be used when we want to have a payoff. And so we can get really specific because if you call the company and say, I want a payoff amount, it's usually different than what you owe. And it might be because they're, compounding it in different ways. So if we wanted to look at a loan balance, we would again use the same formula that we've used before, and we would find out that the balance after 2 years was $7,989.73. Again, just plugging in those numbers to the formula. As long as you keep those straight and don't let the formula be too daunting to you, and make sure that you're using the order of operations, then you should be fine on those. And just keep practicing. That's mostly what's important, is to keep practicing. 10.5 talks about amortization schedules, and it breaks down each payment into principal and interest. And like I've said before, typically this is given to you so you don't have to figure it out. But if you wanted to, you could figure it out, and you could figure out what the payments would be, and just plug it into that formula as usual. And here we have the chart, and you will see that you can set up the chart the same way we have looked at it before. Look at the payment, the interest paid, the principal, and then the balance at the end of that period. And so you can start plugging it in and figuring out what the balance would be after the end of each time period that you would pay. And this is just going down for each of the payments and adding what the balance would end up being for those. And so then you can get a chart and you can figure out, oh, how long is it going to take me to pay off that amount if I am making so many payments per or I made this many payments and I pay the interest and the principal, and when will I pay it off? And so here it tells you that after payment number 4, which would be really nice, you would be able to pay it off. Okay, so that's mortgages. Please let me know if you have any questions, concerns about this chapter. Just remember to plug in the numbers. The formula is basically the same that we've used before, the loan formula. And happy figuring out mortgages. Bye for now.